Okay, so up to now we have only looked at proper fractions, but what happens if we have an improper fractions, which means a fraction which means that the degree of the numerator is larger or equal than the degree of the denominator? Well, in that case, for example, if we have 2x squared minus x minus 2 over x plus 1. So here we have n is equal to 2 and d is equal to 1, so it is definitely an improper fraction. Then our fraction, let me just write that a bit closer here, can be written as a polynomial plus our partial fractions. So this will be, we'll able to write this as some polynomial plus our partial fractions. Now, the partial fractions, well, I've only taken one here, so we know that this is going to be a over x plus 1. Let me just choose c over x plus 1, which will make sense in a second. We need to find out what degree the polynomial is. But the degree of the polynomial will be n minus d, and in our case that is 1. So we have a first order polynomial, and we will get ax plus b. So if we have an improper fraction, we can write it as a polynomial of degree n minus d plus our partial fractions. But how to find a, b, and c? Well, what we can do, as these two, we know these are equal to each other, what we do is multiply by the denominator. So we get x plus 1 times 2x squared minus x minus 2 is equal to x plus 1 times ax plus b plus our c. And you'll see we'll have a third order equation here, and we will have a, I'm missing an x. Sorry. We have a second order equation. We're multiplying both sides. So multiplying 2x squared minus x minus 2 over x plus 1 with x plus 1 will just yield this. So we have a second order equation here and a second order equation there. That makes more sense. Well, we can write this all out. We get 2x squared minus x minus 2 is equal to ax squared plus a plus b times x plus b plus c. And so what we get is we have a bit of x squared there, a bit of x squared there. We have a bit of x here and a bit of x there. And we have a constant term here and a constant term there. And all those things must be equal to each other. Which means we get, again, 3 equations. We get 2 is equal to a. We get minus 1 is equal to a plus b. And minus 2 is equal to b plus c. Well, the first one immediately yields a is equal to 2. So if a is equal to 2, b must be equal to minus 3. And if b is equal to minus 3, c must be equal to 1. And so we can write 2x squared minus x minus 2 over x plus 1 as 2x minus 3 2x minus 3 plus 1 over x plus 1. And if we now want to, wanted to do the inverse Laplace transform, we know what to do with this, we know what to do with this, and we know what to do with this, because they are now all in the Laplace transform table. But if we have an improper fraction, we can write it as a polynomial plus a proper fraction, and we know what to do with proper fractions.